Good evening, dear students. How are you? Hope you are fine. Welcome back to my physics class. Today, I am here, Mafruha Shati, lecturer of physics. Today, I will take class of standard 9. Dear students, today I will explain a very interesting chapter, that is effect of heat on matter. Today's topics are heat and temperature, thermometric properties of matter. Dear students, here you are seeing two nice pictures. I think you can understand when the girl is eating ice cream, she feels coldness or cooler. And here the girl is sweating in the sunny weather. That means she feels hot or hotness. So these feeling of hotness or coldness has a name. Do you know? That is named as heat. Yes, today I will explain you what is heat. Heat is a kind of energy which creates the sensation of hotness and coldness. Heat is a form of energy that can be transferred from one object to another, even created at the expense of the loss of other forms of energy. All matter is made of tiny particles called atoms, molecules, and ions. These tiny particles are always in motion, either bumping into each other or vibrating back and forth. It is the motion of the particles that creates a form of energy called heat or thermal energy that is present in all matter. The unit of heat is joule. Dear students, I think the question will arise in your mind why the unit of heat and work is same, that is joule, though they are the different or separate quantity. Yes, though heat and work is separate quantity, but they have the same unit, that is joule, because both of them are the transformation of energy. Work means also transformation of energy, and heat also means transformation of energy, so that they have the same unit. But previously, heat was measured in the unit of calorie, where a calorie is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie is equal to 4.18 joule. Now I will show you how heat is related to kinetic energy. Heat is simply a form of kinetic energy, the total kinetic energy of random motion of all the atoms in an object. Temperature is a measure of the amount of energy per molecule, whereas heat is the total amount of energy possessed by all the molecules in an object. What we mean by heat energy is nothing but the combined kinetic energy of the molecules of the substance. Let's look. If heat is given to solid, then what will happen? When we apply heat to any solid object, we see that all the particles are vibrating, and the particles are vibrating in their respective position. They will not displace from their own position. But if we continue to apply heat, then we will see what? The more the molecules are heated, the more the vibration increases. If the molecules are heated enough, the molecules become free, overcoming the intermolecular force in this picture, in the second picture. Okay, here the molecules are vibrating more faster and they are overcoming the intermolecular force, and we call this situation as liquid. Then the molecules move randomly among themselves. Since the molecules are in motion, so they have kinetic energy. The more the molecules are heated, the faster they will move. If the molecules are heated more, then what will happen? The more the molecules are heated, the faster they will move. So if the molecules are heated more, they may have completely free from their intermolecular force. In this picture we are seeing intermolecular force, then we call it as gas. The more a gas will be heated, the faster its molecule will move. The more the velocity, the more the kinetic energy. So obviously we can tell heat is nothing but the combined kinetic energy of the molecules of a substance. It is, I can give you one example. যখন তোমরা খুব সুন্দর একটা গান শোনো, সাপোজ তোমরা সবাই, আমি জানি যে পপ সং শুনতে খুব ভালোবাসো, যখন তোমরা খুব সুন্দর একটা পপ সং শোনো, আই থিঙ্ক তখন কি হয়, তোমাদের মধ্যে থেকে অটোমেটিক্যালি একটা নাচ শুরু হয়ে যায়, ইজন্ট ইট? এবং সেইখানে যদি তোমার অন্য বন্ধু বান্ধবও থাকে, দেখা যাবে যে তুমি যখন নাচতে শুরু করবে তখন তারাও কিন্তু নাচতে শুরু করবে। দ্যাট মিনস all will be influenced by that pop song. Just this is happening here. When heat is applied, the particles will be vibrated. এবং the more heat will be applied, the more vibration will be occurred here. Look, here heat is applied to any object, then the vibration will occur, and these vibration will influence the other particles to be vibrated. Okay, so in this way all the particles will be vibrating. So look here, all particles in a solid vibrate even when they cold. At higher temperature they vibrate faster and take up more room, expand, but the particles themselves are still the same size. Now I will explain you what is internal energy. So if we accept heat as the energy, then at the same time we have to know how heat energy is transferred from one place to another. Generally we think that heat energy always flows from higher energy to lower energy, but the flow of heat doesn't depend on the amount of heat, rather it depends on the amount of temperature. Suppose the amount of heat energy that is contained in a glass of water is much more than that of a small hot pin. But if the hot pin is put into the water, a small amount of energy of the pin will transfer to the water of the glass. Because of this, the flow of heat energy does not depend on the amount of heat. It depends on the temperature. If two bodies of different temperatures come in close contact with each other, always heat transfers from the body of higher temperature to the body of lower temperature until the temperature of the two bodies become equal. Look, here you can see there are three containers. In one container, hot water. In the middle container, tap water of room temperature, and in this container, ice water. Okay, and the boy is immersing his two hands in one hand, his left hand in the hot water and his right hand in the cold water or ice water. Okay, so his left hand will feel hotness and his right hand will feel coldness. Okay, but later on what will happen, you see, later on he will immersed his two hands, that means both left and right hand, in the water of the room temperature, and he will observe that the hand which felt hot, that will be colder, and the hand which felt cold, that will be hotter. And if he kept his two hands in the tap water of room temperature, after some times both hands will reach to the same temperature, and that we call as thermal equilibrium. So when two objects of different temperature are kept in thermal contact, then heat always flows from high temperature body to the low temperature body. Look, here a coffee mug is kept, hot coffee mug is kept in the surroundings, whereas the surrounding temperature is cooler, and the temperature of the hot coffee must be greater than that of the surrounding. But after some times we will see the coffee will get cooler, but the surroundings will get warmer. That means heat is the flow of energy from a high temperature location to a low temperature location. Look, here two blocks are made of identical materials, but they have different initial temperature. The block A has initial temperature of 40 degrees Celsius and the block B has initial temperature of 10 degrees Celsius. But when they kept in close contact, in thermal contact, then what will happen? Heat will be flowing from one object to another. And from which object? From that object of higher temperature to the object at lower temperature. And after some times they will reach to the similar temperature that is 24.7 degrees Celsius. And that situation is known as thermal equilibrium. So now we will understand what is temperature. Temperature is such a thermal condition of a body which determines whether the body will receive or give up heat when it comes in thermal contact with another body. And temperature can be measured by using thermometer. Here a clinical thermometer is shown here in the picture. So what is the unit of temperature? Yes, the unit of temperature in the SI system is Kelvin and its symbol is K, capital K. You have to remember one thing. 1 Kelvin is 1 by 273.16th part of the triple point. So you have to know what is triple point. The triple point of a substance is the temperature and pressure at which the three phases, that means gas, liquid and solid of the substance coexist in the thermodynamic equilibrium. The triple point of pure water is at 0.01 degrees Celsius, 273.16 Kelvin or 32.1 degree Fahrenheit. Okay. So 1 by 273.16 part of the triple point of water is called 1 Kelvin. Here the picture is showing triple point situation. That means where the gas, liquid and solid are found in one substance. You know, temperature can be measured by using thermometer, but thermometer can be made by using thermometric property. So what is thermometric property? When an object receives heat and its temperature increases, several of its physical properties can change. A property which changes with temperature is called thermometric property. This can include volume, pressure, electrical resistance, EMF and color. With one of these properties, the thermometer can be made. Dear students, one thing you will do when you will watch my video content, you must write down all the definitions because these are very much important for your knowledge based question. So I may give you what is thermometric property, what is temperature, what is heat, what is the unit of heat. This type of question I can give you. So you must write down and you must make a note. Here I have shown you different thermometers which are made by using different thermometric property. Okay, this is thermistor, which is here the thermometric property is resistance. Then mercury thermometer, where volume is changed with the increase of temperature, and there are other thermometers which are made by using different thermometric property. So different thermometric properties and thermometers. Volume expansion of a gas thermometer. Volume expansion of liquid, laboratory or clinical thermometer. you will see while measuring your body temperature, the mercury level will rise with the increase of temperature. That means here the volume of the liquid is increased. Volume expansion of a solid by metallic strip thermometer. Then pressure change of a fixed mass of gas, constant volume gas thermometer. Change in EMF, that means electromotive force, thermocouple. Change in electrical resistance thermometer or thermistor. So thermometer can be prepared by using two fixed points. One is lower fixed point, that is the freezing point of water or melting point of ice, because you know freezing point of water and melting point of ice is same, that is 0 degrees Celsius in Celsius scale. And the upper fixed point is taken as the boiling point of water. Look, here I have compared between Celsius and Fahrenheit scale. So in Celsius and Fahrenheit scale, in both scale, the boiling point is 100 degrees Celsius in Celsius scale, and in Fahrenheit scale it is 212 degree Fahrenheit. And the freezing point is 0 degree Celsius in Celsius scale and 32 degree Fahrenheit in Fahrenheit scale. And the difference between upper fixed point and lower fixed point is known as fundamental difference. This difference is 100 in case of Celsius scale, and here it is 180. And between these lower and upper fixed point, the thermometer is divided in 100 divisions in Celsius scale, and here in 180 divisions in Fahrenheit scale. And each division of Celsius and Fahrenheit scale is known as 1 degree Celsius or 1 degree Fahrenheit. Look, here I have compared between three thermometers, three scales, that is Fahrenheit scale, Celsius scale and Kelvin scale. Fahrenheit and Celsius I have discussed in the previous slide, and here you can see the boiling point of water in Kelvin scale is 373.15 Kelvin, and freezing point of water or melting point of ice is 273.15 Kelvin, and the fundamental difference is 100 Kelvin. Okay. Now I will show you how to calculate temperature. So a definite temperature is expressed in the Celsius, Kelvin and Fahrenheit scale as Tc, Tk and Tf respectively. So then we can write this equation. No need to memorize this equation, you have to understand how this equation forms. Look, here the temperature which I will measure in the Celsius scale, that is termed as Tc, and Kelvin scale, that is termed as Tk, and the Fahrenheit scale, it is termed as Tf. Okay, so you will write down at first that Tc, Tk, Tf and subtract the freezing point from that. So freezing point in Celsius scale is what? 0 degree Celsius. In Kelvin scale it is 273.15 Kelvin, and in Fahrenheit scale it is 32 degree Fahrenheit. Okay, and you will divide these quantities by the fundamental difference, that means the difference of boiling point and freezing point. The boiling point of Celsius scale is what? 100, and freezing point 0. Here in Kelvin scale it is 373.15 Kelvin boiling point, and freezing point is 273.15 Kelvin, and here 212 is the boiling point and 32 is the freezing point. So the temperature which you will measure, so you will write down those at first, then subtract from them the freezing point and divide it by the fundamental difference. In this way this equation forms. So finally this equation comes like this: Tc by 100 equal to Tk minus 273.15 by 100, because you know this is also 100, equal to Tf minus 32 by 100. And you can also reduce it more by dividing all the denominator by 20. Then it comes Tc by 5 equal to Tk minus 273.15 by 5 equal to Tf minus 32 by 9. Is this clear to you? Look, here I have shown you by one mathematical calculation how to measure the temperature. This is the equation, and you have to memorize this equation. You understood it, how it forms, and you have to memorize it. Okay, so the any temperature in the Celsius scale is 40 degree, and if we want to convert it into Fahrenheit scale and in Kelvin scale, then how can we convert it? Look, so Celsius and Fahrenheit scale has relation, that is this, C by 100 equal to F minus 32 by 180. You can also write C by 5 equal to F minus 32 by 9. That will be more reduced form. So here C is 40, and you have to find out F. That means here you are converting the Celsius temperature into Fahrenheit temperature. In the same way, here also, this is the relation between Celsius and Kelvin scale. By using this formula, you can convert the Celsius temperature into Kelvin temperature. Is this clear? Dear students, till now you learned many things about heat and temperature. So now you have to know the difference between heat and temperature. I think you can write down many differences. So heat is the form of energy, whereas temperature is the measure of heat energy level. Heat energy raises the temperature of a body. Temperature decides the direction of flow of heat. That means an object will give up heat or takes in heat. That will be decided by temperature. Heat is measured in joules, but temperature is measured in degrees Celsius or Kelvin. There are lots of differences you can also make. That means you can give more example here. I have given here only 3 differences, but you can make more. So today I want to end up my lecture. I think you enjoyed my class, and there are some homeworks for you. That is not that much tough. You have to convert 25 degrees Celsius, a nice warm day, to Fahrenheit. Then convert 98.6 degree Fahrenheit, it is normal body temperature, to Celsius scale, and at which temperature the reading of Celsius and Fahrenheit scales are same. Dear students, you can submit this homework by Saturday. Okay, by Saturday at any time you can submit me the homework in my messenger page. Okay, you can inbox it to me. So till then, stay fine and safe. There is a nice moral for you: be better than you were yesterday. Dear students, I always tell to my students that your competition will be with you. You are your competitor. So goodbye everybody.